Hi guys, so this is classification of functions. I'm working on PP3.1. So the instructions said, hey, determine whether or not this is a one-to-one function, a onto function, both or neither. Okay, and you guys were justifying it. I just expected you to answer it, but it's awesome that you guys are justifying it, because on the quiz and on the test, you will be expected to justify your answer. Okay, so let's go ahead and start with number 1. So first of all, the way that we determine whether or not something is one-to-one or many-to-one, the best way is to do a horizontal line test right here. And it fails the horizontal line test, HLT, okay, and not BLT. Okay, it's dinner time, kind of getting hungry. Okay, so let's go ahead and justify that. It fails the horizontal line test, so let's pick some points on that. So we have that point right there, so f of 4 equals 4, and then we could just pick a point smack dab in the middle, f of 4.5 also equals 4. So two different inputs have the same output, so therefore 4 does not equal 4.5. Therefore this is a many to one function. Okay, now we have to figure out if it's an onto function. So to figure out if it's an onto function, we focus on that that range right there, and it tells us that it starts at -3 and goes to 4. I think there was a typo, or less than 4. Okay, well, it doesn't really matter, because we could actually look. If it's all of those points, then you should have everything filled in between those integers. Okay, so another way to figure out if it's an onto function is to see if your range is specific. And this isn't, because it includes all of this area right in between here. It does not include that area. Here, that's way too much stuff that I wrote. So I can say, I can pick a point here, okay, because it says it's, see, it's between, not a point there. I was just thinking about, okay, so if it's between -3 and 4, so it shouldn't, let's just pick that point right there, okay? So you know that f of x, some input based on the range that they give you, should equal -2.5, okay? But there is no graph at all here. You see, it's blank, okay, along that horizontal line. So therefore x is undefined. There is no element of x, okay? There is no, you can write this in different ways, okay? No element of x. You can say maps or produces -2.5, and 2.5 is included in here. Okay, good job, guys. Number 2. Okay, so first of all, my pet peeve, arrows on functions. Okay, it says here that domain is all real numbers, and range is all real numbers. Okay. Oh, by the way, the last one was not an onto function. So to answer that original question, if it's not one-to-one, if it's not onto, then this would actually be neither. Okay. So let's take a look at number 2. Okay, first of all, we figure out if it's a one-to-one function, and I can actually draw a whole bunch of horizontal lines, as infinitely as many as I want, and you can see that there is no 2 points on that function that intersects that. So therefore, we know it's a one-to-one function, because exactly one element of the domain maps to exactly one element of the range. Okay. Next, we have to figure out if it's an onto function, and notice that they specified the range for us, which is all real numbers. Okay, at any point there's gaps in there in the range, it doesn't work, but the range of this is all real numbers. Okay, so this is an onto function. Okay, because that exactly the description of the range of this graph. So therefore, the answer would be both. Okay? Good job. Number 3. Okay. So let's see. Here is the domain, and there is the range. They've specified that the range is all real numbers. Okay. Now, let's check to see if it's a one-to-one. Horizontal line test. Therefore, it is a one-to-one. Okay. We can figure out whether the range is correct. And range is not all real numbers. It is between y is less than or equal to 4 or greater than or equal to -4. Okay, it's not all real numbers, so therefore this is not a one-to-one. I mean onto. Okay, and I could just pick a point here, which is part of that all real numbers, or -5, or any point, okay, above -4 or 4 or below -4, and I could just say f of x equals 5, and there's no element of x that maps to 5. Okay, so the original question, is it a one-to-one? Is it an onto? I don't know, half? Because the original question was stated funky. Okay, good job. Number 4. Okay, so first of all, is that a one-to-one function? Yes, it is a one-to-one function. Every element of the domain is mapped to exactly one element of the range. Now the question is this an onto function? See this C? They've specified the range, which is DBCA, and C is not, there's no element that gets mapped to, element of X that gets mapped to it. So this is not an onto function. Okay? Good job, guys. Number 5. First of all, is this an onto function? No, this is, a one-to-one function. No, this is many to one. Literally, you can actually see that there's many elements of the X that maps to one element of the Y. So therefore, you can write f of 3 equals c, f of 4 equals c. 3 does not equal 4. Okay? Now, is this a onto function? They've stated that the range is DBC. All of them gets used up, or all of them gets produced somehow. Okay? So that means this is an onto function. Okay? Good job. Number 6. Is this a one-to-one or many-to-one? You see right here. I mean, there's several examples. I can use that example right there. Okay, this is a many-to-one. So f of -1 equals 1, and f of 1 equals 1. So -1 cannot be equal to 1. So therefore, many elements of the x gets mapped to one element of the range. Okay? Next, is it an onto function? Let's look at what they tell us about the range. It is all real positive or 0. All real positive or 0. So 0 is included, and then we have all of the positive numbers. Yes, yes, yes. These are going to be part of it. Yes, 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 yes. Okay, so this is an onto function. Okay, good job, guys. Next, number 7. Okay, so is it a many-to-one or one-to-one? This is an absolute value function, so it's going to look like this. If I draw a horizontal line right there, you know definitely it's not going to be a one-to-one. So this is many-to-one. This is many-to-one, okay? And I can prove that by saying f of 1, okay? What is that? F of 1 is 0, and f of -1 is also 0. Okay, so 1 does not equal -1. Okay. Oh, let's look at the range. Y is greater than or equal to -1. So let's see what actually happened to this function. We started at 0, 0, and we just went down -1. So it starts at -1. So you can actually -1. It starts right there. So it's saying that the range is greater than or equal to -1. That is the correct range on that. So this is an onto function. Okay, good job, guys. Okay, so the next set of problems they want to know, I wanted to know if it was even, odd, or neither. So even, odd, or neither, and then whether it was one-to-one or many-to-one. Okay, those are in the instructions for it. I'm going to write that. Even, odd, neither, and then answer 1-to-1 or many-to-one. Okay, first let's go ahead and figure out. So we're going to put f of -x equals 2 minus -x squared. F of -x equals 2 minus x squared. So therefore that looks exactly like the function. F of x, -x equals f of x. So this is an even function. We know that this is a quadratic. Okay, so I know that quadratics are going to be many to 1. Okay, and I can put in f of 2, okay, equals 2 minus 4, which is going to be negative 2. F of negative 2 equals 2 minus negative 2 squared is 4, which is negative 2. So 2 does not equal negative 2. Let's go ahead and graph it. So it reflected over the x-axis, just like that, and then it went up 2. 1, 2, 1, 2. One, two, and then, okay, so let's go ahead. And the x-intercepts are going to be plus or minus the square root of 2, so it's going to be, so around 1.4, negative 1.4, so 1 point, that's, here we go, like that. Okay, good job. Next one. Okay, let's go ahead and prove. So that equals negative 3x. That's going to be a negative times a negative times a negative, so that's minus x cubed. So let's go ahead and take out factor out a negative. When you factor out a negative, you notice that that value or that expression equals the original function. Okay, so that means that f of negative x equals negative f of x. So this is an odd function. Okay, now let's graph some points on there. Okay, or we can actually kind of put in points. Let's go ahead and just graph it. Okay, so whoops, I'm gonna just test points. Okay, we can put a 0. That's gonna give us a 0. We can put a 1 in there, and that's gonna give us 1, and then 3. That's what, 3 plus 1, so that's a 4. 1, 4. Okay, let's go ahead and put a negative 1. So that's going to give me a negative 3 minus 1. So that's going to give me a negative 4. Negative 1, negative 4. It's going to be interesting, kind of like this. You can put some more points in if you want to. This is sufficient for a graph. Okay, and you notice that this right here is there. You can draw a horizontal line wherever you want, but it's still going to be a one-to-one. Okay, good job. See, after the last unit, how graphing becomes so much easier. Okay, so let's go ahead and put h of negative x. And you guys worked really hard. I appreciate it. Thank you. Negative over negative 2x, and h of negative x equals 1 over 2x. So let's go ahead and erase this. So we do know that. So one thing that we know is that 1 over 2x does not equal the original function. So therefore, h of negative x does not equal h of x. Okay, so it's not even. Now, when we're trying to figure out whether or not h of negative x equals negative x equals negative h of x, we have to kind of do something special with rational functions. Rational functions, we always have to do something special. Okay, so notice that I can actually transform this into a negative 1 over 2x. Right? And you know, this has been taught it is such a no-no. Okay, so but what you do is you can put a parenthesis around that, and now this actually equals the original function, what was in here, and you negated the whole entire thing. Or actually just the numerator. Okay, and so that shows that h of negative x does equal negative h of x. So this becomes an odd function. And the issue is depending on what's in the numerator and the denominator of rational functions, it's going to either be even or odd. So the rule is, if all the signs after you do h of negative x, if all the terms, okay, stay the same or change. So when we put in a h of negative x, it ends up becoming something like x of x squared minus 3 over negative h plus 2, and the original function that we got that h of x is something like x squared plus plus 3 over x squared minus 2. Every single term changed. So I could actually factor out a negative and x squared plus 3 and a negative x squared minus 2. And that cancels out negative 1 over negative 1. So that's an even function. Okay? Now, if h of negative x, just like the one that we just did in this example, if just the numerator or denominator, just one of them, okay, change the signs, then this implies that that is an odd function. Okay, just like we had originally here, I can take this negative and rewrite it as negative 1 over 2x. And if you take a look at what h of negative x produced, we went from a positive to negative, just one of the just the numerator. Okay, so therefore this implies that it's an odd function. Now if I graph this, the asymptote is going to be x equals 0, y equals 0, just like that. And let's go ahead and put some points in. Okay, let's try 1. So that's going to give me, let me go ahead and negative 1 over 2 times 1, which gives me negative 1/2. 1, negative 1/2. And then if I put in negative 1, negative 1 over 2 times negative 1 equals 1 over negative 2, which is positive 1/2. Positive 1/2, like that. So rotational symmetry 180 degrees, or rotational symmetry 180 degrees. Okay, we can take one of the points, for example, 1, -5, and what that does is if x is y, then it's going to be -x and -y. Okay, so this was a +1 and a -1/2. So both of the signs are going to change, -1 and +1/2. So when you graph it, you can also see that it is rotational symmetry. Okay, this is going to be a 1-to-1 function also. So it's odd and 1-to-1. Okay, good job, guys. I had to free up some storage. These videos take a lot of space, and a couple weeks I've made really lengthy videos. Okay, next we have p of -x equals 2 -x minus 3 squared. Okay, let's go ahead and, well, I could actually take out a -1, and that becomes x plus 3. I could square it, and I can square these individually. And then multiply that by 2. So that becomes 2 times x plus 3 squared. Okay. Well, if you take a look at that, it doesn't fit into either. I mean, if you, so this function is actually neither, because there you see that it doesn't look like that. You don't have a negative out here, and so p of -x does not equal p of x, and it doesn't equal -p of x. Therefore, this is neither. So let's try to graph this. This is a quadratic function that has been transformed right 3 times. Okay, so 1, 2, 3. And then first point is going to be up 2 to the right 1, up 2 to the left 1. This is the way that it's, whoops. This is the way that the quadratic is going to look. Okay, now our definition is even if symmetric about y equals 0, or the y-axis, and odd if 180 degrees rotational symmetry. So for this, you'll have points like x and y becomes -x and y. And for this, you'll have points like x and y becomes -x and -y. So it's neither. So for a quadratic, if it has up or down movement from the parent function, it's still going to be even. But if it has left or right movement, then it's no longer going to be even. Okay? Good job. Okay, let's go ahead. Oh, by the way, this is a many-to-one. And a many-to-one. Let's take a look at this one. We have f of -x equals, it's going to be -x, then -1x. I can actually take out a negative, x plus 1 over x. Like that. So that tells us that f of -x equals -f of x. therefore this is odd. If I want to graph it, okay, that's x equals 0 is still the vertical asymptote. So x equals 0. Go like that. And this one doesn't have a horizontal asymptote because y could actually be 0. If y was 0, you can have x plus 1 over x. Because of the fact that it has that constant there, I mean, I could put a 1 over it, and that becomes, let's see, x squared plus 1 over x. Okay, and this could actually equal 0. And we now turn this into a completely different rational function. Okay, you notice that the denominator is still x equals 0, but the numerator, okay, is no longer a constant. Okay, it's a quadratic. This is going to have what you call it's a slant asymptote or an oblique asymptote. Okay, and the way that you would find that is you would take the denominator and divide it into the numerator. Okay, but we know that it doesn't have a y intercept. I mean asymptote. So let's go ahead and graph it. Okay, and let's go ahead and pick 1. And that's going to be 1 plus 1, which is 2. And to figure out a little bit more about that graph, I'm going to pick 2. And 2 plus 1 over 2. So that's 2 and 1/2. 2.5. And then I can go ahead and find 3. And notice what happens. 3 and 1/3. 3 and 1/3 is going to be right here. And then we can go ahead and let's go ahead. I'm going to try some fractions. So I can put a 1/2. That becomes 1/2 plus 1 over 1/2, which becomes 1/2 plus, what's that, 2. So 2 and 1/2. What was 3? 3 and 1/3, and 2 and 1/2. So it kind of repeats. So 0.5 and 2 and 1/2. Okay, so let's go ahead and do this kind of thing right here. I'm going to put -1. -1, that's going to be -1 minus 1/2. So that's -1 and 1/2. -1 and -1/2 right here. Okay, and then we're going to have, what was it? -1 and 1/2. And then -2 is going to become -2.5. So -2 and -2. -2. That's my dog barking. And then -1. I'm running out of space. I shouldn't have written this so close to this. Okay. And then we have a -1/2 is going to become -2.5. So -1/2 is going to be -5, just like that. It's going to look something like this. I could put -3. So 3 and 1/3. -3, 3 and 1/3. So it's going to expand out a little bit more like this. Okay, What's important is these two sets of points right here. Go ahead and highlight it. Right here, and one, where was the negative one? Yeah. Did you notice that it went from an xy to a negative x, negative y? So that tells you that's odd. Okay, so what would be this? Is it a 1-to-1 or a many-to-1? This is a 1-to-1. Oh no, it's not. Right here. It's a many-to-1. I'm sorry. Okay. Good job. Next one. Let's go ahead and put f of negative x equals negative x minus 2 negative x cubed plus negative x to the 5th. So that equals negative x minus, that's going to be a plus because they're going to a negative that comes out of that. So plus 2 x cubed, and then we have a negative is going to come out of that. Okay, f of negative x. So my question to you is, did it turn every sign the opposite sign? Every term the opposite sign? So yes. So this would be an odd function. And I can actually rewrite this and take a negative out, and it becomes x minus 2x cubed plus x to the 5th. And you can clearly see that all kinds of alarms are going off. Okay. You can see that whatever's inside of the parentheses now looks exactly like the function. So therefore, f of negative x equals negative f of x. Okay, so let's go ahead and graph this. Let's make our table. There's no asymptotes. Start with 0, 0, 0, 1. It's going to be 1 minus 2 plus 1. That's going to be also 0. So 1, 0. Let's try a point in between and see what happens. Okay, let's try 1/2. And that is going to give you a 1/2 minus 2 times, is it 1/8 plus 1 over 32. Okay, then be 1/2 minus 1/4 plus 1 over 32. Let's go ahead and put that into the calculator. 1. It's not working very well, is it? Yeah, I just didn't want to get out my graphing calculator. Hold on just a second. So that's 1/2 minus 1/4 plus 1 divided by 32. So that's 0.28125. Somewhere here. So what happens is that this goes up, and if I put, what was that? 0.3. Okay, if I put -1, that's going to be a negative, a -1, and then that's going to be a +2 and a -1. So that is going to give me a, is it 0 again? And then if I put in a -1/2, it's probably going to be somewhere here. Okay, if I put in a -1/2, and then you can put it in a -0.5, store it as x, and let's just put in the whole thing, x minus 2x to the 3rd plus x to the 5th. See, it gives you the negative of that 0.3. So negative 0.3. And you can clearly see that this is becoming an odd function. Okay. If I put some more points in, you're going to realize that you get kind of a parabola going on over here and kind of a parabola going on over here. So this is clearly an odd function. You can tell by these two sets of points right here. Okay. So let's go ahead and determine if it's a one-to-one or a many-to-one. This is a many-to-one. This is a many-to-one. Okay. And by graphing it, you can tell. And it's that little area right here that kind of makes it many-to-one. Okay. Well, good job, guys.